All right, in this video, we're going to be exploring and applying sine law. A little less on the exploring, a little more on the applying, simply because it's more important you know how to use the sine law if you wish to delve yourself into where it comes from a little bit more deeply than what I'm going to explore. Feel free to do that. So, as you've seen with right angle triangles, trigonometry can be very helpful to solving, but not every triangle is right angled. So what do you do then? And that's where another law called the sine law, and another one you're going to take a look at in another video will be cosine law, becomes very helpful. So the experiment basically went this way. So I've got the information here on the screen. So just a very basic idea. Using a non-right angle triangle, so that being ABC here, this one on the outside, how would you then find certain side lengths if you needed to? Well, by using a right angle triangle and primary trig ratios, you can set up an equivalency, and that's what the sine law is all about. So the sine of angle B in the right angle triangle, so here's angle B, sine of angle B is this h here, which is really the height of the triangle, divided by c, which is the hypotenuse. Again, we're just focusing on this right angle triangle to get that. And then in the other triangle, in triangle CAD, you can set up a different sine ratio for angle C here. So angle C is in there. And then we have the opposite, which is the h and the hypotenuse versus b. Now, both of these formulas have the same variable. So what does that allow us to do? Well, much like equations of lines, you can isolate for that variable and do a little substitution. All right, so they both have that h in common, so you can rearrange the formulas to get a connection between the ratios that you were given. And then what that allows you to do is manipulate the formula in such a way that it is convenient to remember. Okay, so this equivalency here, so isolate both of those formulas for h, set them equal to another, and then do a little bit of algebraic simplifying. Yes, you can solve for b, but the format that you see down here in the box is the convenient one, and it's convenient for lots of reasons. If you notice, the letters are the same, one's capital, one's lowercase, but the important thing is that the value on the bottom is the side length that is opposite the angle denoted in the sine ratio. So just go back up here. So opposite in the bigger triangle, angle B is lowercase b. And similarly, opposite the angle C in the bigger triangle is lowercase c. So that's why this format is convenient to remember. And it's a lot easier to remember. Okay? So in a very similar fashion, I noticed angle A and side length A aren't included here, but you can go through the same type of explanation. Notice the height of the triangle has now been shifted from where it was here, but now you can also consider this to be a height and do a very, very, very similar process to what we did with the previous one to come up with a different formula that involves sine A and lowercase a, side A. Okay? So the sine law then simplifies to this particular form down here. Now it's a little bit unusual because you're not used to having two equations, or two equal signs, I should say, in a formula, but this is where you have to understand these are three different ratios, and they're all equivalent. And this is for a non-right angle triangle. Okay, you really shouldn't be using this with right angle triangles, although it could be. This version of the formula that you see here, sine law, is convenient to use when solving for angles. Now, why? That's because the capital letters are representing angles, and they're in the numerator, and it's always easy to solve for variables that are missing when they're in a numerator. So that would mean you would need numbers to replace the denominators and then manipulate the equations how you need to get the solve. You can easily take the reciprocal of each one of these and come up with a different look for the sine law. And this formula would be used when you're solving for side lengths. So again, because the side lengths are in the numerator. okay? Now, basically how these ratios or proportions are set up is you would use them in pairs. So you'd identify which pair is going to be able to be used to answer any problems that you may have. Okay, so you shouldn't be using all three at the same time. That's too confusing. Okay, so solved in pairs. So to do that, then you either need two angles and an opposite side. So angle, angle, and an opposite side. So then you can use those two because you would have a missing value here. Or you could have two sides and an opposite angle. So if you had the two sides and an opposite angle, then this could be a missing side length. So it really depends on the information. One of the most convenient ways to do it is just write out all the information, fill in the formula, and then it should be pretty easy to decide which two of these ratios you're going to set up an equation for and then solve. That's what we're going to take a look at now. Okay, so suppose you're given triangle XYZ. You're given the angle Z, angle X, which is lowercase, you notice, so it's not an angle, not at the vertex, and lowercase z is 64. You're asked to find angle X rounded to the nearest degree. So what's extremely important here is that you label your diagram properly. So do you have angle X? No, you don't. You have a side length for X, you have a side length for Z. Now, so labeling this is extremely important. So the capital letters are the vertices, where the angles are, okay? And then the lowercase are the side lengths opposite to what you're given, all right? So the lowercase z would be opposite angle X, angle Z, and the lowercase x will be opposite to angle X. And notice this is not a right angle triangle. Okay, that's important too. So just doing a little reference diagram here. If you don't set up this diagram properly, then you've already likely going to not succeed in solving the question properly. So you're asked to find angle X. So by simply filling in all the information that you have, so here's the sine law. Because you're solving for an angle, as I suggested, you use this version where the capital letters and the sine ratios are in the numerator, and just fill it in. And notice it's not A, B, and C either because the letters are X, Y, and Z. So you fill in all the information that you have given to you. So you have an angle for Z, you have the side length for lowercase z, and you have the side length there. And you're asked to find capital X. So if you have part of this ratio complete and all of this complete, then you're going to set up an equation between these two ratios. That one there and that one there. You can't use the middle one. There's nothing, no information for you to use. So you set up an equation using those two ratios. Now you have a way of solving for X. Multiply both sides by 42. Calculator is going to be extremely handy. Make sure your calculator is in degree mode to be able to get the proper answer. So your sine of X is going to be equal to, so all of this using a calculator becomes 0.4475. Still need to find that angle X. That was the goal. So use the inverse function in your calculator to get an approximate result to 1 decimal place. Now it did say nearest degree, so probably better off rounding that to 27 degrees, but 26.6 is pretty accurate. Okay, so again, using a non-right angled triangle, fill in the information that you have, decide what you can use, solve using appropriate techniques, and everything should be fine. So similarly here, now you're asked to solve the triangle. So you have some information given with triangle A, B, and C. Round your answers to 1 decimal place. Now solving a triangle, what that basically means, you have to find all the angles in the sides. Luckily, you're given 3 pieces of information already because you need to find all 3 angles and all 3 sides. So again, looking at the information you're given and how you can find a few things. Now there's nothing wrong with using prior knowledge too. So you're given 2 angles in the triangle. To find the third, how would you do that? Correct. You just subtract from 180 because all 3 of those angles must add to 180 degrees, as you know. So right away, you can check off because you already have angle B and C, and it's easy to find angle A. So you don't have to get too sophisticated. If there's a technique to use from prior knowledge, then go ahead and do it. So the two things that are missing now are side length B and side length C. So again, side length C is over here. So let's put a little lowercase c there. And side length B is over here. So those are the two things you need to find in this triangle. Okay, because we have everything else that we need. So you probably guessed it, since we're using sine law, we can set up a formula using the capital letters. Now notice I've used this version of the formula that has the lowercase letters because that's what we're trying to find. So this is the version we're looking at. So A over sine capital A and so on. And then again, fill in the numbers that you have and leave the ones that you don't. Okay, so we have all this information given to us. We calculated A, so we can put all that in there. So if we're trying to find B, well, this ratio is complete. This one is not complete. I can use it to find side B. So to find side B, I can use those two ratios, set an equation together, and do the same thing with this ratio and this one here to find C. Different equation, notice different colors, and then use exactly the same techniques to solve as in the previous one. Just a little inverse operation and then solving for the side lengths. So here the inverse operation would be multiply both sides by sine of 26. Remember, this goes together. And then this bracketed part becomes 28.55 using your calculator. Sine of 26 is 0.4383. Always have an extra 2 extra decimal places in there. Multiply them together to get C. Same sort of technique here to find B. You'd have to multiply both sides by sine of 83. And then a lot of calculator work and careful arithmetic to get your answers. Okay. All right. So where else can this be used? Obviously some word problems. Now you have to understand some of the language here, but other than that, it's pretty straightforward. So you have the roof of a new house must be built to exact specifications so that solar panels can be installed, very environmentally friendly. The long rafters at the front of the house must be inclined. Now inclined is a fancy way of saying elevation at an angle of 26 degrees to the horizontal beam. So the hardest part with these questions is coming up with some information that you can fill in with regards to diagrams. So this one has a little bit of a picture associated with it. Okay, so the horizontal beam is right there. This is the roof at the top. You notice it's a triangular shape. And the rafters are basically the beams that are used to create the shape of the roof itself, right? So the long rafters at the front of the house, so apparently this is the front of the house, must be inclined at an angle of 26 degrees of the horizontal beam. So that's why this is 26. So the long rafter is 26 degrees from the horizontal. The short rafters must be at an angle of 66. So the shorter beam here, shorter rafter, and there's the beam, and there's the angle, has to be 66. The house is 15.3 meters wide. So if it's 15.3 meters wide here, guess what this measurement is? Exactly, 15.3. You're asked to determine the length of the long rafters. So you have to find this length in here. So drawing a reference diagram for just the roof, just this roof over here, just that triangle right here. And you can use whatever letters you'd like. So we have the 26 degrees and the 66, just like in the picture over here. Again, this angle up at the top can be calculated by subtracting from 180. Okay, so that'll help possibly answer the question. We're asked to find the length of the long rafter, which I've labeled as X. So your sine law, why this can be used, well, you have two angles and a contained side length. So this would be, let's see, if we did this side and this side, well, the angle opposite 26, not helpful. I don't have any information and I really don't want it. So I want the ratio with the sine of 66 and X, and the sine of this angle and 15.3. This one would be a completed ratio. And notice I didn't write out the entire sine law, all three of the ratios, because it wasn't necessary. So the 66 degrees is opposite the x, there's one ratio. And this angle up here, which is 88 degrees, is opposite the 15.3. So that is enough for me to be able to solve this problem because I'm looking for x. Okay. Once you determine all that, again, it's a matter of just inverse operations, coming up with the correct answer, and you are done. All right, so the hardest part with all the questions involving sine law is making sure you have an accurate diagram, it's labeled properly, get the correct ratio, set up between the two, or set up an equation with the two ratios, and then properly and carefully calculate. So it's about just being very meticulous, and more often than not, things will work out for you. Okay, so hopefully this video will help you understand some of the concepts in this lesson.